All right, good afternoon, everybody. We'll go ahead and get started. As we go through today, feel free to send in any questions you have using the question and answer interface here in Zoom. And I will do my best to try to answer those as we go through. So today we're talking about our wireless products. This is sort of an introduction to our wireless APs. In the past, we've done, specific presentations on specific access points, and we've done some sort of deep dives into Wi-Fi technology. So today is kind of an overview of the wireless offerings that we have here in North America. So to start off with, we sort of break up the products into two different categories. Um, Let me get my laser pointer going. So at the beginning here, we've got our flexibility. So these are products, if you look at the model numbers, after the letters, they will start with either the number 1 or number 2. So examples of this would be the NWA 1123 AC Pro, the NWA 210AX, etc. So these products are all part of our Nebula Flex family of products. So that means they can be used standalone. So you can just interface with their GUI directly to manage them, or you can manage them in the Nebula cloud. On the higher end of things, our Ultimate series, these are going to be products where the model number starts with a 5 or with a 6. So examples of this would be the NWA 5123 ACHD, the WAX 650S, stuff like that. So these products are all fall into the category of what we call Nebula Flex Pro. So like the Nebula Flex products, you can directly manage them. You can choose to use the cloud to manage them. And in the case of the Pro products, you can also manage them with a controller. So these days, most of our Zyxel products or USG, the VPN series, they have built-in wireless LAN management capabilities. So these access points in the 5 and 6 series can be managed by those controllers. These products also tend to have some more advanced technology when it comes to the antenna technology and some of the other stuff going on. So some of the things you will find in this series would be dual optimized antennas, smart antennas, default outdoor enclosures, built-in Bluetooth low energy radios, monitoring radios, etc. So whether we're talking about our cheap $85, $89, 1123 ACV3, or whether we're talking about our flagship WAX 650S, we use the same design philosophy when it comes to building the hardware. If you pick up one of our APs and compare it to some of our competition, whether it be Ubiquity, whether it be Ruckus, and you hold them in your hand, you will notice our AP feels a lot heavier. We used to bring other RAPs and other vendors' APs to the trade shows. So if you've been to meet us at a trade show, you may have actually been able to experience this at our booth. You can feel the difference, and when you open them up, you can see the difference. So what is it that we're doing here? So access points are a solid state technology. There's nothing moving in there. So what causes a solid state device to fail? So there's two main culprits generally that would cause a solid state device to fail. One would be capacitor failure. A lot of devices are using electrolytic capacitors. They're basically little barrels that are filled up with salt water. So over time, those can fail. They can leak, they can just dry out and evaporate, they can burn up. So on all of our access points, we only use solid state capacitors. We do not use any electrolytic capacitors. The other major cause of failure over time is heat fatigue. Basically, as solid state components here are exposed to large amounts of heat, it can cause the individual switches inside the chips to start to fail. It could also cause some of the solder joints to crack and create separation so you don't get as good connection as you need. So to combat that, if you look at our housing, all of our housings are designed with a lot of vent holes to allow heat to escape from the housing. If you look at some of our competitors, they have no vent holes at all. So there's no place for that heat to go. On top of that, we'll have this giant what do you want to call it? Heat distributor, basically, or a heat sink that goes behind the PCBA and draws the heat off the board and helps vent it out of the top of the unit. So that keeps those solid state components from suffering from heat fatigue over long term. Another big difference that we do is we do not mount our antennas directly onto the PCBA itself. Instead, we've got a noise spreader that sits above the PCBA, and then the antennas are mounted onto that. So again, even on our cheapest APs, we use this design philosophy. So by separating the antennas from the PCBA, you get just that much a little bit better receive sensitivity. You will also notice a lot more RF shielding on the PCBA itself. So if you look at our competitors, you'll normally see one or two little sections of RF shielding, where if you look at our PCBAs, you'll see a lot more RF shielding. And again, that's just to help reduce electromagnetic interference on the board just that much and give us just that much better receive sensitivity. So let's talk a little bit about some of the different technologies that are out there when it comes to the antennas. So most access points that you buy are designed to be mounted on a ceiling, pointing down, and they radiate out their coverage in what's basically a large circle or an umbrella shaped pattern. So that's how most of your APs are designed. So it's great if you're able to centrally mount that AP in the area you want to cover. But oftentimes when you're doing installations, for whatever reason, you cannot mount onto the ceiling. So instead, you have to mount onto the wall, which is the antenna pattern is not designed for that. So you end up sending a lot of your signal up into the ceiling and down into the floor. If you're on a multi-floor building, you can cause interference on the floors above and below you. So one of the solutions we had to that is something called dual optimized antennas. So with dual optimized antennas, we have two sets of antennas built into the AP instead of the standard one you'll find on most of our competition. One antenna is designed to be mounted onto the ceiling in the traditional way. And then we've also got a second antenna that's optimized for if you're mounting it on a wall. So you can switch between that antenna pattern based on where you're installing the access point. So no matter if you're mounting it on the ceiling or on a wall, you have an optimized antenna pattern that's going to give you the best performance in that situation. Another technology we have out here is our smart antenna technology. So before we get into what smart antenna does, I do want to take a step back and talk a little bit here about how RF works. I'm not going to go in depth as we do on our normal Wi-Fi 101, just covering some of the basics here. So Wi-Fi operates on one of two spectrums. It operates either at 2.4 or on the 5 gigahertz spectrum. The 2.4 gigahertz spectrum is only around 60 megahertz in width, and a single 11B Wi-Fi channel uses around 20 megahertz of bandwidth. So because of that, here in North America, you can only have 3 different channels in use before you get overlap. And anytime you have channels overlapping, you're going to have interference. So part of the challenge here is going to be then if you have more than 3 devices within range of each other, they are going to overlap. Another challenge here is how we get to the faster speeds. One of the ways we get to the faster speeds that you see claimed on data sheets is by increasing the bandwidth that's being used. So starting with pre-11N, the speed you see claimed for 2.4 are based on 40 megahertz channels. So again, you've only got 60 megahertz total available, and you're using 40 to get your speed on your access point. So if you're using 40 megahertz channels, you can only have one device operating before you start getting interference between the two. So this is called co-channel interference, when you've got multiple devices operating at the same time. So there was a big push to 5 gigahertz because 5 gigahertz opens up a lot more spectrum here for us. So instead of having 3 non-overlapping 20 megahertz channels, you've got over 20 non-overlapping 20 megahertz channels. But you'll notice here in the middle, there's a big chunk of these channels that we've got highlighted in orange here called DFS channels. So basically, before the FCC opened up 5 gigahertz for Wi-Fi usage, it had been used by other devices, in particular radars, whether we're talking airport radars or weather radars. So in order to basically open this up for Wi-Fi use, the FCC put in rules for something called DFS. So with DFS, basically before you can use one of these channels, your access point has to listen to the channel, verify it's not being used by another legacy device, and then once it's established that, it allows you to broadcast. But one of the challenges you run into is, based on weather, based on what's going on, is the channel may be good for a while, and then it will experience some noise on those channels that it'll detect as being legacy usage. And so by FCC rules, you have to stop using that channel. So one of the problems you run into with this is if you're using these DFS channels, it can cause you to occasionally be thrown off your network, and it can take 30 or 60 seconds before you move to a new channel and can resume connecting again. So a lot of users obviously don't like to be disconnected at random times from their network. Another challenge with this is it adds about 6 months to the FCC certification process to sell the product in North America. So a lot of consumer grade equipment doesn't support these DFS channels. So you run into that a lot in offices where people are allowed to bring their own equipment from home. If they've got a more an expensive phone, if they've got something that's new and just came out, it may not support those DFS channels. So we get a lot of calls to tech support saying, hey, we've got 10 devices on the network, but we've got 2 guys that can't get on no matter what we do. What's going on here? And oftentimes the answer is you're using a DFS channel. So because of those reasons, a lot of people choose to not use the DFS channels. So you see a drop from like 20 non-overlapping 20 megahertz channels to the point where you're down to just about 9 channels that are non-overlapping. And again, to get the faster speeds, we're increasing the amount of bandwidth that's being used. So if you're using 40 megahertz channels, you've now only got 4 non-overlapping channels. If you're using 80 megahertz channels, you've only got 2 non-DFS, non-overlapping channels. So because of that, again, you run into situations where people are trying to run their access points at full speed. They're using the maximum channel size they can use. So you quickly run into situations where you're getting interference. So again, that's what we call co-channel interference, when 2 or more devices try to broadcast on the same channel at the same time. If you remember the old analog walkie-talkies, if you ever played with those as a kid, when 2 people tried to talk at the same time on different walkie-talkies, you couldn't make out what they were saying. And it's the same sort of thing that goes on here with Wi-Fi. So here's a little example. In this case, you've got your one access point here. You add a second access point that's operating on an overlapping channel, and you're going to have co-channel interference. So traditionally, the way you would deal with this is you would spend a lot of time carefully planning which channel each access point was on, and then you would reduce the power of your access points to try to keep them from overlapping and interfere with each other, which absolutely worked, but it introduces a whole new family of problems. Lower signal to noise ratio, so you're getting lower throughput, so you're having to use more airtime to transmit stuff. You get coverage holes because you've dropped the power and it can't reach through the wall the way it used to. So the solution to all of this is the smart antenna. So we have these, Ruckus has these, and that's pretty much it as far as the big access point vendors go that have this smart antenna technology. So by using smart antenna technology, you're able to increase capacity, both in the number of users you can get on an access point, as well as the number of access points you can have crammed into the same area, because it reduces interference as well between those APs. And it helps boost coverage by directing the signal to where the users are. So you get better range and better speeds at closer ranges. So again, your traditional AP just broadcasts in a circular umbrella shaped pattern. So in this case, instead of using another AP, we're using a microwave as a source of interference. So with a standard access point, you would get that interference, and it doesn't have to be a microwave. It could be another AP. It could be a wireless keyboard, wireless camera. It could be some industrial equipment. Air conditioners tend to put off a lot of RF interference. So that causes signal to drop. So by using smart antenna technology, we have the ability to go through, instead of just that one fixed pattern, the ability to go through hundreds of different antenna patterns, allowing us to optimize the signal for each access point. So in addition to allowing us to focus the signal or focus the beam to where the client device is, it also allows us to ignore and choose patterns that will ignore sources of interference, whether they be a microwave in this example or another access point. So it makes a huge difference. It doesn't require anything special on the client side. It will work with any client device. It will work with moving client devices, and it has the ability to do this basically in real time for every client that's connected to the access point. So we've got some speed tests here. So in this case, they are comparing us to an Aruba access point, which does not have smart antenna technology. So this is just showing here on the 2.4 gigahertz radio. The speed difference, this isn't the best test because I don't think we dropped our 2.4 radio to 2x2, which the Aruba had. So let's look at the 5 gigahertz radio. So here we're comparing 4x4 11AX to a 4x4 11AX. And you will see significant performance difference between our WAC 650X and the Aruba AP 515. And again, this is because of the smart antenna technology allows it to help optimize that antenna pattern to give you a better signal to noise ratio for each of your clients, which allows them to operate at a faster speed. A few years back, the University of Brescia, and I'm probably pronouncing that wrong, in Italy, that university, their networking group got together and they saw the claims companies like us and Ruckus makes when it comes to smart antenna technology. So they went out there and they tested products to see how it actually performed. So we've got a link there on the page. You can go and pull up their website there. They've got full details of the testing, everything you would want to know. You could also just go to Google, type in Zyxel smart antenna white paper, and we have a white paper put together where we highlight the key findings from this actual university research. But you're more than welcome to go pull up the full research paper that they did. But basically what they did is they went out, they bought our access point, a Ruckus access point, and the equivalent Cisco and Aruba APs, which don't have smart antenna technology, and tested them. And what they found is in a lab, smart antenna didn't make much difference in a clean room environment. But in a real world environment where there are other sources of RF interference, where there's obstructions in the environment and reflections and things like that, smart antenna made a huge difference in the performance of the access points, the wireless clients connected to them. And they found our implementation and our algorithm on the smart antenna outperformed Ruckus. So now let's talk briefly about Wi-Fi 6. So Wi-Fi 6, also known as high efficiency Wi-Fi, also known as 802.11ax, is the first major significant change to Wi-Fi in a long, long time. Basically, they've come along and are trying to address many of the issues that have plagued Wi-Fi for a really long time. By solving some of these issues. The other thing that they've done here is this is the first new Wi-Fi technology since 11N that works on the 2.4 radio. So if you're running an 11AC Wave 2 access point, the previous latest generation, only the 5 gigahertz radio had those improvements. The 2.4 has always been stuck on on the 11N technology. So now with Wi-Fi 6, you get these new improvements on both radios. So a huge performance increase on 2.4. It's been designed to have more devices connected on one AP, and to have more APs in the same area. So you're getting some of the benefits you get with smart antenna technology, but done in a different way. Smart antenna uses physical characteristics of the antennas in the RF environment to improve things. Wi-Fi 6 uses software improvement behaviors in the protocol itself to some of the same things. So combined with smart antenna, you get a fantastic experience. So some of the changes that allow this to take place, you have the ability now to do multi-user MIMO, both from the AP to the clients and from the clients back to the AP, something that OFDA now being used for both downstream and upstream. You have something called resource unit scheduling, which lets you more efficiently use the air QAM so you can cram more data into the same bandwidth. Something called BSS color coding, which allows you to have access points and devices in range of each other on the same channel. And the packets are tagged in such a way that a device knows if those packets are intended for it. And more efficient use here of energy savings when it comes to your mobile devices. So this is just kind of showing here, prior to Wi-Fi 6, you used OFDM, which we talked about before, essentially breaks up Wi-Fi into 20 megahertz packets. So if you're doing something like multi-coverage, or at least 20 megahertz, with OFDMA, it dramatically allows us to assign all sorts of different sizes of packets or airtime available. So when you're doing multi-user MIMO, you can optimize the airtime utilization based on the demands and what is supported by each individual client device, and allows you to much more efficiently use your airtime there. And this is just showing here for BSS coloring again. The packets themselves essentially get tagged. So when a device is there, when it first sees something coming through, it can say, wait a minute, is that intended for me? And if it's not, it can ignore it. So it allows you to better utilize a channel and reduce some of the co-channel interference issues that you would run into otherwise. So all in all, it makes a huge difference in performance. So this is showing with 1AP. We're comparing in sort of yellow here, a Wi-Fi 6 device to in orange, a Wi-Fi 5 device. So what it's showing here is as you add users with Wi-Fi 6, the aggregated throughput stays essentially the same. But because of inefficiencies in how airtime is utilized with 11AC, as you add more users, you actually get aggregated throughput starts to drop. So you add users, each user gets a smaller and smaller portion, much more so than if you were using Wi-Fi 6, where essentially the overall bandwidth is always going to be available. And then you run into the same or similar situation here when you've got multiple APs. Same thing, aggregated throughput stays the same on Wi-Fi 6 versus 11AC, whereas you add more users, the aggregated throughput drops. So much better performance on the higher density deployments. So one thing we unfortunately have to talk about is that there are a lot of products out there that are being marketed as Wi-Fi 6 that don't actually comply with Wi-Fi 6. Basically, the Wi-Fi 6 name was created by the Wi-Fi Alliance as a way of rebranding 802.11ax, but there is no rules about how you use it. Basically, the Wi-Fi Alliance wants everyone to use the new Wi-Fi 5, Wi-Fi 4, Wi-Fi 6 naming. So anybody can use that naming. Now, if you want to have a Wi-Fi 6 certified product, you do have to comply with the Wi-Fi Alliance rules and go through their testing. And their testing requires you support all of these key features in Wi-Fi 6 that differentiate Wi-Fi 6 from previous 11AC Wi-Fi 5. However, there are a lot of companies that are not getting that logo, and they are not calling their product Wi-Fi 6 that don't properly comply. So one of the things you'll run into here just has to do with what generation the chips were. So-called Wi-Fi 6 chips hit the market, over 2 years ago. These are Gen 1 chips, and I've got Qualcomm up here. Broadcom's in the same boat. It's basically the same sort of chart where these Gen 1 chips are missing some of the key features that differentiate Wi-Fi 6 from Wi-Fi 5, and they cannot be upgraded with software. We just had a company who will not be named who just launched a brand new lineup of Wi-Fi 6 products that are still using these ancient Gen 1 chips that are missing some of the Wi-Fi 6 feature set. Another challenge we run into here is, for instance, Ubiquiti on their Wi-Fi 6 access points. They're only putting Wi-Fi 6 on the 5 gigahertz radio, not the 2.4. So when you buy a Ubiquiti Wi-Fi 6 AP, you're still getting 11N technology on the 2.4 radio. So just to make clear, with Zyxel, all Zyxel Wi-Fi 6 products are using the current generation of chips. They support all of the features of Wi-Fi 6, and Wi-Fi 6 is on both the 2.4 and the 5 gigahertz radio. But that's something to keep in mind when you're comparing out there. And these companies don't necessarily make it easy to figure this out. So for Ubiquiti, you've got to go and look on the data sheet and pull up the RF specs to see that the 2.4 radio doesn't support Wi-Fi 6. And for some of these other vendors that are using these old Gen 1 chips, the only thing you can do is look at the data sheet and see, do they mention OFDMA in both directions? Do they mention upstream MIMO? do the mention TWT? Do the mention BSS coloring? Are all those features listed on their data sheet? And the answer is no, they're not, because they're using these older Gen 1 chips. The other thing you can do is you can pull up their FCC ID from the belly label and Google it and see which chip is in there. But that's a lot of work. So just something to keep in mind. Not everything advertising as Wi-Fi 6 is truly Wi-Fi 6, and that includes some new product that launched just this year. So let's go through and talk about some of the stuff here. So on the Ultimate line, as we mentioned before, we have the ability to use an on-premise controller, specifically the controller that's built into the Zyxel series of products. So I'll go through here some of the features that you get with the on-premise controller. For the most part, they overlap pretty significantly with Nebula if you'd prefer to use Nebula. But there are people out there that, for whatever reason, still want to use a local controller. So you get things here like intelligent dynamic channel selection, where the controller decides which AP uses which channel. When you plug in the device and activate the controller on the network, the AP will automatically find the controller, put itself into controller mode, and get its configuration from the controller. We have our Zymesh technology, very similar to the Nebula Mesh technology. So if some of your APs don't have a physical wired connection, they can mesh with other APs to get their backhaul. So it's convenient for, adding a couple APs here and there on the edges where you don't necessarily need the best performance, but you can't get a cable to them or they're too far away from the switches for the Ethernet run to make it. Fast roaming using 802.11 KV and R. Rogue AP detection, the ability to do edge-based security, dynamic VLANs, where VLANs are assigned based on individual user rather than the SSID, advanced AP load balancing, client isolation for guest networks, so wireless clients are not able to send data to each other, they're each individually isolated. Band steering, being able to push users from one radio to the other, captive portal technology. So here's a list of the products that support this. So basically, it's pretty much our entire Zyxel line at this point. The VPN series, the USG Flex series, the ATP series, and even the older USG before the USG Flexes. As you can see here, each device has a default number of APs that it can manage out of the box. And then here on the ATP series, you have the ability to this is showing you here the default number here, 8, or if you buy a bundled version, which comes with the bundled gold license, this is how many APs are managed out of the box. And then you can see here, you can buy licenses to unlock additional APs for management. So you could get up here on the VPN 1000 to manage over 1,000 APs through one controller. So just recently here, Network Advisor did a review comparing us to Ubiquiti. Go check it out. And he's actually, since I made this slide, he's done a second review looking at, what was he looking at? He was looking at another comparison between a different set of our models. So you can go check those out and see what he had to say on things. Now we'll start going through basically our product portfolio. So we'll start here with the 1 and 2 series products. So at the very entry level here, we have our NWA 1123 ACV3, 2x2 spatial streams on both radios. It does support MU-MIMO. We have the NWA 1123 ACHD, which is in the process of being phased out as we move more and more stuff to Wi-Fi 6. And again, guys, send questions in if you can with the question and answer window. I can see that as we're talking here. I can see flashing of the chat, but I can't really read it as we go through until I get to the end here. But I will get to the chat stuff at the end once we get through here. And then we've got the 1123 AC Pro. We've got 2 versions of it. One version which comes bundled with a standalone PoE injector and one which does not. So if you're using switches to power your devices, you'll save a few bucks if you buy the version which doesn't come with the PoE injector. On the Wi-Fi 6 side of things, we have the NWA 110AX and the NWA 210AX. So these are both Wi-Fi 6 devices. The primary difference between the two is going to be the speed of the 5 gigahertz radio. The 110AX supports 2 spatial streams. The 210AX supports 4 spatial streams. And because this one has the faster throughput, it includes a 2.5 gig Ethernet connection on it, where the 110AX is maxed out at a 1 gig Ethernet connection. And then jumping up here into our Nebula Flex Pro products, the 5 and 6 series products, we're going to be launching here soon a WAC 500. So this is going to be a 2x2 access point. And the key thing on this is these WAC 500 access points will be our most affordable AP that supports the new secure Wi-Fi functionality that we've recently launched on the USG Flex series and on the ATP series. We have our WAC 6303D-S. This is our most affordable smart antenna access point. It's 11 AC Wave 2. We've also got our 5123 ACHD. So if you don't need the smart antenna technology, this is a good one to go to. When it comes to hospitality, we have 2 different APs that are designed for in-room usage. So these APs have Ethernet ports built into the bottom, have PoE pass-through on them. The WAC version includes smart antenna technology, where the WAC 500H, the WAC 5302 has smart antenna, the WAC 500 just has standard antenna, and the 5302 gets you an extra Ethernet port and a USB port that it can provide power out through. On the Wi-Fi 6 side of things, we have the WAC 510D. So this is very similar to the 110AX, but it adds dual optimized antennas, as we talked about earlier in the presentation, which will let you change the antenna configuration based on where you've mounted the device. We've got the WAC 610D, very similar to the earlier NWA 210, but again, this one has dual optimized antennas on it. And then we've got our WAC 650S, which is our flagship product. So this has got 4x4 on both radios. It's got a third radio, which just does nothing but scan. So you use this for DFS to more quickly be able to change APs if you encounter any sort of thing. And this one has a 5 gigabit Ethernet connection and Bluetooth built in. And then Rowan here was asking about 6E access point. So for those of you that aren't familiar with it, Wi-Fi 6E has to do with a new chunk of spectrum that's recently been opened up by the FCC. We don't currently have an ETA on when we're going to have one of those here. I think we're starting to see some consumer equipment hit the market which supports 6E. So with 6E, you would have 3 radios, a 2.4 radio, usually a 5 gigahertz radio, and then a 6 gigahertz radio for what the extended coverage is. We're still waiting on the chipsets that support the full business class feature set. So we want to be able to launch a 6E access point, which has the same software features as our existing 5 and 6 series. So we're waiting for those chips to be available, and it's really hard to say when that's going to be, just because everybody's roadmaps and availability are really messed up now due to the IC shortages that are out there. So it's hard to say when that's coming, but yes, we will have 6E access points in the future. And then on the outdoor side of things, we have a 3x3 11 AC AP, which you can connect external antennas to. We have a 2x2 11 AC AP with smart antenna. It's a directional smart antenna, which focuses the beam in essentially a 90-degree angle for outdoor coverage. If you want to do outdoor 360 coverage, you can put 4 of these on the same pole. And they are designed with that smart antenna specifically for that application, so they will not cause interference. And then we've got this outdoor enclosure, which you can use on a number of our APs, including some of our Wi-Fi 6 APs, to help weatherproof them for mounting them outdoors. So if you don't want to buy a dedicated outdoor AP, these will help reduce the exposure to dust and moisture, so you can use indoor APs outdoors in a lot of scenarios. So we'll go briefly through here some of the competition. So we'll start here with the NWA 1123 AC Pro, probably our best-selling Wi-Fi 5 access point. It competes with the Ubiquiti UAP AC Pro. So you can see here, we've got more output power than they do. We support more SSIDs than they have. We have the dual optimized antenna versus that single ceiling only antenna pattern. Higher gain on the antennas. Full support for SNMP V2C and V3 versus only SNMP V1 on the Ubiquiti. This AP is Nebula Flex, so it can be managed in the cloud or standalone. We have what we call dual image firmware. So basically, if you do a firmware update and something happens during the update that causes the update to fail, it doesn't overwrite the previous firmware that was loaded on there. So it will detect a corrupt firmware and fall back to the last known working firmware. So you don't end up breaking your AP. Look at the 1123 ACHD. Again, this one competes primarily with the Ubiquiti UAP ACHD, and it's the same sort of situation, higher output power versus Ubiquiti, more SSIDs, better SNMP management, Nebula cloud support, lower PoE power utilization, that dual image firmware so you don't accidentally end up breaking your AP, and the price should be in the same ballpark as what Ubiquiti charges. And then jumping up here a little bit, we've got the NWA 5123 ACHD. This is kind of like our entry level of the 5 and 6 series. So you can see, comparing us with most of our competition, we've got more power output on than most of them. We've got dual gigabit Ethernet ports where many of our competitors only have one. We've got some of the best, better PoE power draw, so you can fit more APs in the same power budget. And again, that dual image is on there. Let's jump up to Wi-Fi 6. So this is where stuff is newer. So we've got the WAC 610D here. So this would compete with Aruba, the 515, and the Ruckus R650. So the Aruba just has a standard static antenna. We have the dual optimized antenna. Ruckus does have their smart antenna on there. So that's an area where Ruckus is going to beat us a little bit. We've got a little bit better output power here on the 2.4, but we beat out Aruba on both the 2.4 and the 5 gigahertz radio. Greater operating temperature range. And again, we offer the free Nebula Cloud Management as an option here, and this includes 1 year of the Pro Pack with the AP. The 510D would compete with the Aruba 505 and the Ingenious, and now the Netgear version of these Ingenious APs. So a key one here is this Ingenious AP is not true Wi-Fi 6. It is a pre-11AX chipset, and that also holds true for the Netgear AP that's based on the same hardware. So significant improvement in performance and compatibility with the full Wi-Fi 6 spec. Dual optimized antenna versus static antennas here. Higher output power than all of these. Free Nebula cloud management, etc. And then lastly, the WAC 650S. So this competes here with the Meraki MR45, the Aruba 535, and the Ruckus 750. So us and Ruckus have smart antenna. None of the other competitors offer smart antenna technology. Again, better output power than most of our competitors here. Dedicated monitoring radio, something only us and Meraki offer. We've got a 5 gig uplink port where only the Aruba offers a 5 gig uplink port. So the other models here, you're going to be bandwidth constrained by your 2.5 gig Ethernet connection. And again, the Nebula Cloud Management. So that's it for today's presentation. Marketing wants me to be sure to let you guys know to check out our LinkedIn, where we are on there as Zyxel US channel, and on YouTube, where we are Zyxel America channel. So that's where today's webinar, if you came in late, if you have people on your team that you think might be interested in this, this is being recorded. It will be posted to our YouTube there, so you will be able to find it in the next day or two. And otherwise, we'll open it up to any questions that you guys have. Feel free to start typing those in. While I wait for some questions to come in, let's just address here. We do have user forums, forum.zyxel.com. If you haven't already checked them out, unlike a lot of our competitors, we do have staff monitoring those user forums, and they do weigh in, oftentimes answering questions, providing solutions, and just keeping an eye on feedback of what sort of features people are looking for. So it's a great way to reach them directly with feedback. And then my email is up there on the screen. It is Sean R. Sean is spelled SHAWN, then the letter R at Zyxel.com. Feel free to give me feedback on today's presentation. Feel free to give me ideas for other webinars you'd like to see me put together that you think would be beneficial for you or your team, or just ask me questions offline. Feel free to do that. And let me pull up chat real quick. Nope, nothing new there. So with that, guys, it looks like that's it for today's webinar. Thanks for joining us. I'm going to go ahead and end the presentation. Thank you, everyone.